Hello everyone, and welcome to this video titled Translate Between English Phrases and Algebraic Expressions. In this video, I'm going to be doing several examples taken directly from the practice at a website called ck12.org, and I'm specifically in their Algebra 1 text. So here I am at the practice for translate between English phrases and algebraic expressions at ck12.org. I'm going to be going through 5 examples, and if you ever find yourself in their Algebra 1 text and are practicing this particular one, you can go through all 10 and, master the skill, and even after you've, quote unquote, mastered it, you can go back in and practice as much as you like to your heart's content. All right, so the first example I'm seeing here, and I would highly recommend that when I start a new example, try to pause the video and try to work it out yourself before you watch me do it and see how I'm doing it and compare your work to mine. So we're told here to write a variable expression for the verbal expression. So the verbal expression here is the difference between a number and 8. All right. So pull on the scratch pad. So here we're asked to write, the, oop, why is that doing that? Okay, my apologies. Let me scrap that. All right, so it's the difference. It's happening again. Okay, my apologies. Let's get back into this one more time. See if my pen tool won't go haywire on me. All right, the difference between a number and 8. Okay, so the key word here is difference, all right, or difference between. Whenever you see the word difference in mathematics, difference will imply that you are doing some sort of subtraction. Right? So difference between is subtracting two quantities. Then a number, I noticed in all the options for the problem, they had the variable or the letter x that will represent this number, right? Typically you do that in mathematics, take a quantity that's unknown, like this number that they speak of here, and give it a variable expression, call it something. I'm calling it x. And of course, this number here, the number 8, is just the number 8, right? So we're taking the difference between a number and 8, right? That would simply be subtract x and 8, right? X minus 8, the difference between a number x and 8. Very simple. I apologize for the pen tool issue a minute ago. So of these choices, that looks like choice C. Check it out. Great. All right, so next example. We have here 4 times the quantity of a number plus 6. So I'll write that out in my scratch pad. So once again, we have 4 times the quantity of a number plus 6, I believe it was. Yes, the quantity of a number plus 6. Right. So first, the number 4. The number 4 is simply going to be, the number 4. Here's a keyword, right? Times means, multiplication, which I can represent with a dot or a little x, like not a fancy curvy x, like the variable x, but, this symbol here. So just straight x like this, this multiplication. But usually I'll use the dot or just have things touching one another. Usually in algebra, when expressions are just touching with parentheses, that implies multiplication. When you see the quantity or the quantity of, what comes after those words should be in parentheses. Right? So the quantity of a number, right, which, like in the previous example, I'll represent this unknown number by curvy x, a fancy x, the variable x. And then plus, right? Plus means addition, right? So plus. And then the number 6, the number 6. But that a number plus 6 after the quantity of should be in parentheses. So we have 4 times the quantity of, so 4 dot, parentheses, and inside the parentheses is the quantity, a number plus 6, and then close parentheses here. This number plus 6 is the quantity they speak of, right? When they say the quantity of. And so here we go. This is our expression in words written in algebraic symbols in mathematics. And now they don't have the dot, right? Like I said, you can just have quantities touching sometimes, but look in choice B. You have 4, and then right immediately next to it, the parentheses implying multiplication, the quantity, a number plus 6, x plus 6. Check it out. Wonderful. All right. After this, next example. All right, here we're told that Tom cut a red rope into 5 equal pieces that were 9 meters long and had 12 meters left over. If the red rope was twice as long as a blue rope, what was the length of the blue rope? And then you enter your answer in meters, and it says enter your answer as a decimal to the tenths place. To the tenths place, right? So right after, you have a whole, the ones place point and then a decimal point and then the tenths place after that. All right, so a red rope into 5 equal pieces that were 9 meters long and had 12 meters left over. All right, so I'll draw a little picture of that. Let's actually make this red. Let's change this to a more reddish color. This might be orangish, but so here's this red rope. There's the red rope. And let's go back to black here. And they said he cut it into 5 pieces that were 9 meters long. Okay, so this is 9 meters, this is 9 meters, 9 meters, 9 meters, and 9 meters again, right? There's your 5 equal pieces of 9 meters long. And then they said with 12 meters left over. So the length of the red rope, right? The length of the red rope is, 5 times 9 meters, right? There's 9 plus 9 plus 9, that's 9 times 5, right? And then add to that the 12 meters left over, and we can simplify this, 9 times 5 is 45, and then plus 12, after. Remember, you do multiplication before addition in your order of operations, and this would be 57, right? 57 meters long, little m for meters. All right, so then this blue rope, all right, maybe I'll change the color to a bluish color. Now, I'm not going to draw the blue rope. I'll just write out an expression here. They said the blue rope was half the length, right? So half the length, half of, right, half times, and then, the length of the red rope. I'll just say half red. Well, that means the length of the blue rope is half of 57 meters, right? Which is, 57 over 1 if you want to think of it as a fraction. And when you multiply fractions, you multiply the numerators. That's 57 in the numerator. Multiply the denominators. 2 times 1 is 2 in the denominator. And they asked us to write this as a decimal, right? So right now I've got a fraction, 57 divided by 2 meters. But they asked us to write this as a decimal to the tenths place, so I'm actually going to perform the division. Now 57 divided by 2, 57, how many times does 2 go into 57? That'd be 28 times, right? With one left over, right? Because 2 times 28 is 56. You'd have one left over, 1/2 left over, and a half as a decimal is, 0.5. So there we go, right? Here's what we're going to be entering. The length of the blue rope would be 28.5 meters. Go to this blank here and include 28.5. It's to the tenths place and check it out. Wonderful. All right, let's keep moving. All right, so this is another similar one. All right, so this time instead of writing out full words, I'm just going to use the letters, right? I said that before. Usually things instead of, just to save on writing, very often certain quantities will be represented by a single letter, right? A single variable. So here, Sarah cut string A into 8 equal pieces that were 3 meters of, and there was 3 meters of string left over. Each of the 8 equal pieces was 6 meters long, right? So this is very similar to the previous example. Right, and then it says here, string A is, right? So, right, when you see the word is or some version of the form to be, is, are, was, were, that will represent equals, equality, equation. So string A is 3 times the length of string B. What is the length of string B? And they want to fill in the blank with meters here. Right, so oops, I didn't enter an answer. I want to go to the scratch pad. My apologies. All right, so to the scratch pad here. So let's do string A. All right. So string A, and cut this up. That said Sarah string A up into 8 equal pieces, and those pieces were 6 meters long with 3 meters left over. All right, now I can draw a little diagram, cutting it into 8 equal pieces. All right, so here's your 8 equal pieces. Now, I know that's probably not a great, to scale drawing here, but each of these were 6 meters apiece, right? So there's 8 of these sixes, right? These are all 6 meters apiece. And then what's left over was 3 meters, right? So the length of string A is, 8 times 6, right? That's the 8, 6 plus 6 plus 6 plus, 8 times. And then add to that the 3 left over, which is 48, right? 6 times 8 is 48 plus 3. So that's 51 meters, right? 51 meters. So the length of string A is 51 meters. Now, the sentence after that, string A is 3 times the length of string B. So I'll use A for string A's length. Is equals, and then three times. And then the length of string B is another quantity I don't know. I will use B for that. All right, so we have this equation now. Right, the length of string A is equals 3 times the length of string B. And so if I were to, manipulate this equation here, remember, what you do to one side of an equation, you must also do to the other side, right, to keep it balanced. If I want to solve for B, if I want to get B by itself, right now it's multiplied by 3. Undo multiplication by using division. So now I will divide that side by 3 and also divide this side by 3. Right, and then you can see on the right side, 3's are now a common factor in the numerator and denominator, right? So 3's cancel or divide out to be 1. And what I'm left with is, B will be equal to, I'm just kind of switching sides here. We have B on one side, and then the other side will be the length of A divided by 3, which, I know the length of A from the previous step, right? From the previous sentence, I substitute that in, and we're getting 51 meters, but, divided by 3, and that's 17. Right? 3 goes into 51, it's 17 times. So here it is. That's what, B equals, right? What I have down here is B equals 17 meters, which is, 1/3 of the length of string A, or string A is 3 times the length of string B. Means the same thing. So 17 meters to fill in the blank. Let's check that out. Wonderful. And then I'm going to do just one more problem. But hopefully you've noticed what's happened here in all these examples. When you're trying to translate between English phrases in algebra, if there are, quantities mentioned, the length of string A, the length of string B, or just a number, like in the first two examples, usually you're going to replace those, replace those words with a letter, right? The length of string A, I called A. The length of string B, I called B. The number, those unknown numbers from the first two examples, we called X. And then you also need to, go through and look for key words, right? Difference meant subtract. Plus meant add. The quantity of meant you were going to be putting parentheses around some expression, right? The words after the quantity of. Is means equals. Times means multiplication. Usually of, like in the quantity of. The word of will imply multiplication as well. Half of, quarter of will be multiplication. There are many, many, many key words that I'm not gonna write them all here. I'm doing a few, you can obviously read through the text, whatever textbook you're looking through, especially here at ck12.org, look in their Algebra 1 text, and they should be, in this particular section going over some common key words that you'll come across and how to translate them into math, algebraic symbols. All right, so one final example here. All right, so here we have a train has 6 identical passenger cars that are each 13 meters long. The train's boos is 10 meters long. The train is twice as long as a truck driving next to it. What is the length of the truck? So this one's very similar to the string problems. And so I'll draw this out. So we have this train. Let me actually pull this up so maybe you can see I'll just put it on here. So I'll draw a picture of the train, a very, very basic picture of the train. I'm going to make my train look like my strings from earlier. there are 6 identical cars. So 1 car, 2 cars, 3 cars, 4 cars, 5 cars, and 6 cars, right? So here are the cars, and they said that each of these cars is 18 meters long. So that's 18 meters, 18 meters, 18 meters, 18 meters, 18 meters, and 18 meters. Right, and then you have this caboose. Now I'll say, typical classic looking train, the caboose is red, You have this caboose that's 10 meters long. So the length of the train, I will use train, all right? So for the train length, all right, train length, I'm going to call this capital T. They also have truck later, so I'll use a different letter for truck so we don't get confused. Capital T, all right, and then capital T will represent the train length in meters, and it is, 6 times 18, right? There are these 6 cars, each with a length of 18 meters, and then plus, the length of the caboose, which is 10, and 6 times 18 is, 60 plus 48, that's 108, plus 10, so this is 118 meters, right? The length of this train. All right, and then they said there's a truck alongside it, right? So the truck length, I'm going to call that something else, right? So I'll actually call the truck length X. Again, I don't want to use T again. I don't want to confuse myself. I don't want the same letter representing 2 different quantities. That would be very confusing. And if I call the truck length X, right, we can use the last statement again to write an equation, right? There's the word is again in this last sentence, right? It says the train is. So the length of the train equals twice as long as the truck driving next to it. Twice is like 2 times, right? When you say twice or double, that's 2 times. So the length of the train, which I called T, is equals twice the length of the truck, right? Twice as long as the truck. So 2 times. So down here, I'll write this equation, right? They said the length of the train, right? The train, which I called T, is equals, and then 2 times the length of the truck. And so, if I want to find the length of the truck, I want to get, x alone. I don't want 2 times x. And then just like in the previous example, if I'm multiplying x by 2 and I want to get rid of that 2, we do the inverse operation of multiplication, which is division. To undo multiplication, you divide. So I'm going to divide by 2 on the right, and if you divide by 2 on one side, right, you have to do it on the other side as well. And you see on the right side of the equation, 2's are now common factors in the numerator and denominator, so they will divide to be 1 or cancel. And so I have now x by itself, right? What we're seeing here is x will be equal, right? So x on one side will be equal to p divided by 2 on the other side, right? And we know t, right? We know the length of the train that was given to us, right? 6 times 18 plus 10. All right, so 118 there. So I'm replacing t with 118. And then this is getting divided by 2, getting cut in half. And 118 divided by 2 is 59. Right, so here it is. There's the value of x. We have x equals, right, let's follow the equals here, equals 59 meters. And what was x? X was, the length of the truck. So my final answer here, right, what is the length of the truck? 59 meters. So now they already have meters up here, so I'm just putting in 59 and then check it out. Excellent. All right. So And I've been saying when you're reading through English phrases and trying to translate them into algebraic expressions, I would first identify quantities that you don't know or things that can take on a value, right? Like the length of the train, the length of the truck, length, width, volume, area, distance, weight, you know, cost, things that can take on quantities, take on values, and call them something, X, Y, Z, or something that you can recognize more easily. And then using those letters, using those variables that you've assigned, you go back through and read it again and see if there are any key words that might hint at what kind of algebraic expression or equation you might write, like is, or twice, or times, or decrease, increase, plus, minus, difference, product, quotient of, the quantity of. There's all sorts of stuff. That again, if you read through your text, should be, they should highlight at least the most common ones you might come across. But you read through and find common words or some key words that will help you take your letters, take your variables, and write an expression or an equation or an inequality with, is less than, is greater than. And then you go through and solve that equation, solve that inequality, and answer the question that they're asking. All right. So thank you very much for watching. Again, you can continue practicing on your own here. I hope this helped a bit. Take care.